Okay, we're starting off with the big idea of algebra, which is the idea of variables. Now, a mathematical quantity is just anything that can be measured or counted, and some quantities remain the same, but others will change or vary, and they are called variable quantities. When something is variable, it is able to change, or it has a potential changing state, changing value. So we use symbols to represent quantities that are unknown or that vary. If we don't know them, it might have a constant value and we just don't know it, but it could be that it's varying, and so we can't just call it a single number because it's going to change depending on certain things, other things changing. So you can represent mathematical phrases and real-world relationships using the symbols and operations of algebra and mathematics. So a variable is just a symbol, which we usually use a letter and very often use an X, but don't get stuck on X as always needing to be the letter. That represents a value or values of some variable quantity. When you have some expression and it's got one or more variables, we call it an algebraic expression. An algebraic expression refers to expressions that contain variables. So this is going to go along with it. If it's got a variable, it's going to be an algebraic expression. Numerical expressions involve numbers and operation symbols, but there's no variables in it. So numerical has to do with just numbers. And once you say algebraic, because algebra is dealing with variables, if you see a variable in there, it'll be an algebraic expression. For this course, you are going to be given problems throughout the lesson, and you're going to have to see how these ideas are used and then use them yourself. So, problem 1, writing expressions with addition and subtraction. Here is a couple of word phrases, and what could we use as algebraic expressions to represent these word phrases. And the phrase in this case, A, is 32 more than a number n. We're going to start with the number n. That's the variable. We don't know what that number is, this quantity here. And we're going to go 32 more than that. So we start with n, and then we go 32 more than that. Now, we could say we've got 58. This is the whole amount, 58. And then we go less by this number n. We don't know how much less we're going, but what we're talking about is what's left then. 58 less this amount will be 58. We're starting there and then taking away that amount. How can the diagram help you? Well, models like this one can help you visualize the relationship. So hopefully you can see what we're talking about here, where we say 32 more than a number, you have a number, 32 more than that. Or in this case, you have the whole amount 58, and then you go less by that amount, n. Now it's your turn to try this problem. These are got it problems, and the got it problems, you will stop and solve them and then compare your answer to the answer that you get after you restart the video. So give a shot at this. What is an algebraic expression for 18 more than a number n? All right, so now we're going to write algebraic expressions with multiplication and division. What is an algebraic expression for the word phrase 8 times a number n? And this should help you here. That says we're going to take that number n 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And the algebraic expression will describe that whole amount of that n taken 8 times. You can write it as 8 times n with the x, or with a dot, 8 times n, or 8n right next to it. You could also write 8 parentheses n. All of those things are multiplication. And there is multiple ways that you can write multiplication. It says using a dot or parentheses, and these are a few of the ways. Now look at the second one, the quotient. Now if you know that this is the answer to what kind of problem, it's going to be helpful. Quotient indicates division, and you should learn that if you don't know that yet. the quotient of a number n and 5. Now, the first of the two terms, since it's division, the order matters, and quotient is suggesting that we need to start here. We're saying we're taking n, and we're dividing it into 5 equal amounts. And with division, you are always talking about equal amounts, 5 equal amounts. So here we take this full n, and if we cut it into 5 equal sections, how much would each section be? You can write it as n divided by 5, or you can write it as a fraction or a ratio, n divided by 5. And you should see this as a division problem. And just as a little hint, writing any fraction like n over 5 as we see there and putting dots where the number and the variable are gives us the division symbol. So this division symbol is really just a fraction with dots where the numerator and denominator would be. So you can see a fraction and a division symbol as both representing division. Okay? Now, you have a task to do, which is your got it problem. And this got it problem here, give it a shot. You're going to write your answers down and then restart the video to check your answers. All right, so what if we had two operations? How would we do it? What's an algebraic expression for the word phrase? This first one, A, is 3 more than twice a number. What we first want to do is take twice the number because we need something to go 3 more than. Right? We have to have a starting point, and that's twice some number x. Well, how can we visualize that? And it would be helpful if you drew a diagram like this diagram here, where you have that number that you don't know x, you have it twice, and then you go 3 more than that, and you're talking about this entire part here. Okay? And what do we get? We get 3 plus 2x. And you should hopefully understand through the commutative property of addition, which we'll cover again, that 2x plus 3 is the same amount. When you're adding amounts, you can put them in any order and it won't change them. We will cover the commutative property. Letter B, 9 less than the quotient of 6 and a number x. Okay, well, before we can go 9 less than it, we need to have this. We need to have the quotient of 6 and a number x. And remember, when we have quotient, order matters, so the first thing that comes first goes on top. So we will have 6 over x, that came first, so that's on top, over x, and then we need to go 9 less than that. 6 over x, or 6 divided by x, minus 9. And we've got one more, and that is the product of 4 and the sum of number x and 7. This is a little tricky, so let's break it down here. We're having the product, or product is the answer to a multiplication problem. We're doing the product of two things. We're multiplying two things. We're multiplying 4 and what? And the sum of these numbers. So in order to multiply 4 with the sum, we need to get the sum first. Then we could say 4 times that amount. So the first thing we need to do is have the sum of x and 7. Sum means add, so we're going to add x plus 7, and then we will multiply that sum by 4. And you can see that x plus 7 is in parentheses because parentheses, as we will cover next lesson, makes something that was going to happen later happen first, order of operations. So we get the sum of these two numbers, x and 7, and then we can have the product of 4 and that sum. Yep. So now it's your turn. Here's your got it problem. And, excuse me, while I move that, you're going to stop and write down what you think is your best answer for this, and then start it up and check it against the answers that are provided. So in those first 3 problems, we were given word phrases, then we wrote the algebraic expression from the word phrases. We can also go the other way. We can also take an algebraic expression and then write word phrases from that. So what word phrase can we use to represent the algebraic expression 3x? You might have picked up as I just said that this is one way of writing multiplication. So you can think of this as 3 times x. Number and a variable side by side indicate a product being multiplication. So we can use words like times or product to indicate multiplication. 3 times a number x, or 3 times x. I'm okay if you leave out the part a number and just say 3 times x. But the product of 3 and x, or the product of 3 and a number x. Now, is there only one way to write an expression in words? Nope, because you can use multiply, times, product, all of those words interchangeably, or to indicate the same operation. You can use them, each of them differently, and you could write it in multiple ways. Okay, so now is your got it problem. You're gonna stop and write your answers for all of these. You're gonna write your word phrase, and please do it. Write down your answer before you move on, so that you're genuinely getting the practice that you need in order to master this lesson. All right, so here we're going to use words or some algebraic expression, and we're going to write a mathematical rule for real-life patterns. You'll see what we're talking about in just a second. So here our little character is building a house of cards, and we can see that the table is 24 inches high, and then each level is going to add to the total height of this structure an additional 3.5 inches. Now it says the table below, which is this table right here, shows how the height above the floor of a house of cards depends on the number of levels. If we had 2 levels, we would have 2 groups of 3.5, 3.5, 3.5, and then that 24 inches of height of the table. If we had 3 levels, we'd have now 3 groups of 3.5, 1, 2, 3, adding to the 24 inches of table height. And with 4, etc. Now what would happen if we had some unknown number of levels? We could write some algebraic rule for any number of levels that we could then plug in the number of levels if we wanted to calculate how tall would the entire structure be off the floor. If we had 13 levels, we could put 13 in where n was, and we could solve it out. Okay, so what do we know? Okay, we have numerical expressions for a couple of different levels like this. These are numerical expressions. There's no variable, so it's not an algebraic expression, just numerals and symbols, so numerical expression. We need to find a rule for finding the height for any unknown number n levels, the total height. So if we look for a pattern in this table, we can describe it in words and then describe it with an algebraic expression. But what is going on here? Here's how we can write this. For words, we could just say you multiply the number of levels by 3.5 and then add 24. That's the rule that's going on here, yeah? And the variable n represents the number of levels of the house of cards. So 3.5n means you multiply however many levels you've got by the height of each one, 3.5, and then add this 24 on the end. And this is going to be a common theme that you're going to hear me saying is there's this one-time amount of 24, and then there's this recurring amount of 3.5. That recurring amount that happens some number of times is going to be what the variable multiplies, and we call that the coefficient, and this will be the constant, okay? Okay, let's apply the same idea to these 2 other problems. A group of students built another house of cards that had 10 levels. Each card was 4 inches tall, and the height from the floor to the top of the house of cards was 70 inches. Now, they're not giving us the height of the table, they're giving us the total height. Okay? How tall would the house of cards be if they built an 11th level? Well, let's think about it. We already know how tall that house of cards is with 10 levels and how tall is each level. Each level is 4 inches tall. So we could just take the height that it is with 10 levels, and adding one more level would add one more height of 4 inches since each card is 4 inches tall. So we would increase it by 4 inches. So we would say we have 70 total inches plus another 4, or 74 inches tall in total. Now, what about this last one? Another group of students built a third house of cards with n levels. We don't know how many levels there are now. Each card was 5 inches tall, and the height from the floor to the top of the house of cards was 34 plus 5n inches. We can see that must mean that the table was 34 inches tall, and then there's some unknown number of levels, each 5 inches tall. How tall would the house of cards be if the group added one more level of cards? Well, adding one more level would add what more? We would be adding one more group of 5 inches. So how can we take that? Well, we're adding 5 more inches on. Since each card is 5 inches tall, adding one more level would increase it by 5 inches. So now we've got the original expression, which is 34 plus 5n, and then we just add 5 inches onto that. And of course we can combine this right here. These constants can go together, and we'll do that as we move on in this course. But right now you can just see that we take the original amount, like you did here, 70, add the 4 inches for each 4 inches height per level, and here we take this algebraic expression for the height that we have with some number of levels, and then one more level at 5 inches each. Okay, so you've got a problem here. I'm going to just point this out real quickly before you start to set it up. Suppose you draw a segment from any one vertex. The vertex is one corner of a regular polygon, and draw it to the other vertices, of course not going along the edge because there's already a side there, right? You're splitting it up into triangles. Write a rule for the number of non-overlapping triangles formed. If you go here, there is, in this case, 6. So you have 6, and how many do you get? You have 2 less than that 6. You have 1, 2, 3, 4. You can draw some polygons, and you can start at a vertex and draw to all the other vertices that aren't already sides, and see that you always end up with 2 less than the number of sides that you have. So what if you had n number of sides? Okay, what is a rule in words and as an algebraic expression? You're going to stop now and get your answers down for this, both in words and as an algebraic expression, and then check your answer against what's posted. All right, that brings us to our lesson check. This is going to be at the end of each lesson. It's a small set of problems that you can just verify that you understood the basics of what's going on. So the video will stop, and you can work on these problems and record the answers for as many of them as you can get, hopefully all of them, and then you can restart to check your answers. Good luck.